Let me ask you a question. What if the most fundamental thing you think you know about the world, the very ground beneath your feet, was up for debate? Today, we're diving into a text that does exactly that. Eric Dubay's 200 Proofs Earth is Not a Spinning Ball. In this explainer, we're just going to break down the core arguments presented in the source material, looking at the claims one by one.
So the source material organizes its arguments into a few key themes. We're going to walk through 5 of them. We'll start with what we can supposedly see with our own eyes. Then we'll get into the physics of water, followed by large-scale engineering, the problem of motion, and finally, we'll look at the logic of airline flights. So let's jump in.
Okay, so the very first category of arguments in this book is all about personal observation, what you and I can supposedly see for ourselves. And it all begins with the horizon.
According to the text, it doesn't matter if you're using amateur balloons, rockets, or drones. The claim is that the footage you get back shows a consistently, completely flat horizon. The source argues that the only images showing curvature come from government space agencies, which it suggests should be viewed with a bit of skepticism. So this idea really boils down to 2 core visual claims. First, that the horizon is always perfectly flat, a full 360 degrees around you. And second, that it always seems to rise right up to meet your eye level, no matter how high you climb. The text argues this just wouldn't happen on a sphere. On a ball, the higher you go, the more you'd have to physically tilt your head down to see the edge, or the horizon. Building on that idea of visual observation, the next set of arguments moves into physics, and specifically the natural properties of water. The central idea here is pretty straightforward. Water's natural physics is to find and maintain its level. You see it every day. The source presents this as something that makes perfect sense on a huge, flat plane, but not so much on the outside of a giant spinning sphere. And the source tries to put some hard numbers on this. It gives a specific formula, stating that on a sphere of the accepted size, the surface should curve downwards 8 inches per mile squared. So, as you see here, the book argues that over a 6-mile stretch of water, the middle should be a full 6 feet higher than the ends. And the claim is that this curvature has just never been detected. From physics, the source material then pivots to the practical world of engineering. The argument here is that the people who literally build our world operate as if it's completely flat.
The book points to massive projects like railways and canals as Exhibit A. It focuses on the Suez Canal, which is 100 miles long and, crucially, has no locks. The source says it was built along a single horizontal line, 26 feet below sea level, with absolutely no allowance made for any supposed curvature of the Earth over that massive distance.
And to really hammer this point home, the author includes quotes like this one from an engineer named W. Winkler. He's quoted as saying that the very idea of allowing for curvature, which he calculated as 600 feet over a 30-mile canal, is as absurd as trying to square the circle, something no engineer would ever waste their time on. So the essential point being made here is that the professionals who build our infrastructure, we're talking canals, bridges, railways, they just don't factor the Earth's curve into their plans. The book's conclusion: if the Earth really were a ball, these projects should be impossible. And yet, there they are. This brings us to a whole set of arguments about motion. The source starts asking questions about why we can't see, feel, or measure any of the effects of an Earth that's supposedly spinning at over 1,000 miles per hour at the equator. Let's kick this off with aviation. The text actually calculates that for a pilot to keep a constant altitude while flying at 500 miles an hour on a globe, they would have to be constantly dipping the plane's nose down. We're talking a descent of 2,777 feet every single minute. The source says without that constant correction, they just fly straight off into outer space. And this same idea is applied to all sorts of other examples in the text. It asks things like why a cannonball fired straight up in the air lands right back next to the cannon, or why can't a helicopter just hover in the air and wait for its destination to rotate underneath it? It even points to Felix Baumgartner's famous high-altitude jump, noting he landed just a few dozen miles east of where he took off, not thousands of miles to the west, which the source claims should have happened on a spinning surface. All right, the last category of proofs from the source that we're going to look at zeroes in on modern airline travel. The text claims there are some major oddities, especially when you look at flights in the southern hemisphere. The author really frames this section with a direct question, pretty much asking why the actual flight paths we see in the real world just don't seem to make any sense on a standard globe model. One of the key examples given is a flight from Santiago, Chile to Sydney, Australia. Now, the book argues that the shortest, most direct path on a globe would be a straight shot right over Antarctica. But it claims that what really happens is that these flights take massive detours way up north, stopping in places like Los Angeles. The author's contention is that these bizarre, winding routes on a globe magically become almost straight lines when you plot them on a flat Earth map.
And the source contends this pattern just keeps popping up. It claims a flight from Johannesburg to Perth, Australia, for some reason stops in Dubai, or that a flight from Cape Town to Buenos Aires routes all the way through London. The argument presented is that these layovers seem completely illogical on a globe, but they suddenly become efficient travel options if you're looking at a different projection of the world. So to wrap it all up, the arguments laid out in the source material really stand on these main pillars: what you can supposedly see with your own eyes, the way water behaves, how we actually build things, what we can't feel, and finally, how we travel around the world.
And that really leaves us with the final and most provocative thought from this explainer. The source material is fundamentally asking the reader to weigh their personal observations, their own senses, against the established scientific models. It frames the entire debate as a choice between what you can actually see and what you are told you should be seeing.